Hi. So far we have learned about analytic functions and also the Cauchy-Riemann equations. Okay, so these equations are very important and we will be using these equations very extensively in this module. And now we will do some deductions from this Cauchy-Riemann equations. Okay, so before we start, let us recall the Cauchy-Riemann equations once again. So if f of z is equal to u plus iy is analytic, you know that ux is equal to vy and uy is equal to minus vx, or dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. So we have derived these equations before, and also we know the value of f dash of z. So many values are there, but one value is ux plus I vx. So using Cauchy-Riemann equations, you can generate other formulas also. Okay, so with all these concepts in mind, let us now derive some the problems using this Cauchy-Riemann equations. Okay, so first let us look at this question here. An analytic function with derivative 0 is a constant. Okay, so before we start with this problem, you know that a function whose derivative is 0 is always a constant from real analysis. Okay, so if there is only one variable on x, you know that if the derivative is 0, definitely the original function would be a constant function. So we are actually carry overing that result to complex analysis. Okay, so suppose we have an analytic function, okay, whose derivative is 0. Okay, that means we are going to prove that it is a constant. Okay, how can we prove that? Okay, so in every problem, start with the first principle. So you just define an analytic function. Let f of z is equal to u plus iv be a analytic function. Okay, you'll start every problem will start with this statement. Okay, and it is given to you that what has been given to you? It has been given to you that the derivative of this function is 0. Okay, so what is f dash of z? They have told you that f dash of z is equal to 0. Okay, so in every problem, start with this statement. Okay, then write what is given to the problem, and you will have to use Cauchy-Riemann equation somewhere in that problem for every question coming from the first module. Okay, so this much you know. Okay, and now you know what is f dash of z. I have already told you, we have already derived what is f dash of z. What is the value of f dash of z? F dash of z is actually ux plus I into vx, right? Okay, now it is given to you that this is actually equal to 0. So what can you say of ux? Ux is equal to 0, Vx is equal to 0, because two complex numbers are equal if and only if their real parts and their imaginary parts are same. So your Ux is equal to 0, Vx is equal to 0. Okay, now if you know this thing, it is already given to you that your analytic function, the function is a given function is analytic. So what can you say about Vy? What will be the value of Vy? Okay, you know that Ux is equal to Vy, so Vy should also be 0. Okay, similarly, what can you say about Uy? Now Uy is minus Vx, and that is also 0. Okay, so now we have got that ux is 0, uy is 0, vx is 0, vy is 0. Okay, what does that mean? Now you can see that you know that u is basically a function of x comma y, and v is also basically a function of x comma y. Okay, and now it is telling you that ux is 0, means u will not contain any terms involving x. That is why when you took differentiation derivative with respect to x, it became 0. Why? Because there was no term containing x in u. Okay, that is why when you took the derivative with respect to x, you are getting 0 value. That means u will not contain x terms. Okay, similarly, what can you say about y also? When you are differentiating u with respect to y, you are getting 0. That means there is no y term present in u. That means u will y, that means y will not be there in u also. So u does not contain x terms and y terms in this case. Okay, so u does not contain x terms and y terms. So what will u be? So it can maximum be a constant. Okay, I hope it is clear. Why? So you know that u, for example, if you take an example, for example, if it is your u is 2x square y, when you take derivative, what will you get? You will, if you take ux, what will you get? Ux will always be 4xy. Okay, so since there is a term of x involved, the derivative will not be 0. Okay, but if there is no term involving x here, suppose u is 2y, and if you are taking ux, you will get 0. That means there was no x term in this original function. So that was the idea which are using here. Okay, it is given to you that ux is 0, that means u does not contain x terms, and similarly uy is 0, that means u does not contain y terms. So maximum u can be 0 or it can be a constant also. Okay, even if u is equal to 2 also, these relations will hold, right? Because if you take derivative of 2 with respect to x, you will be getting 0, derivative of y with respect to y, you will be getting 0, so it can be a constant. Okay, so u is a constant. Okay, on a similar note, we can also derive that v is a constant, because vx is 0, there will be no x term, Vy is 0, there will be no y term, so maximum v also can be some other constant, maybe it is d. Okay, so from this what will you get? Now you get that your function f is equal to u plus iv has become c plus id, where c and d are constants, therefore f is a constant. Okay, very straightforward calculation using just your derivative formula and the Cauchy-Riemann equations. Okay, very simple problem. Okay, so we will do some more similar problems also, like this one. Okay, an analytic function with constant real part is constant. Okay, so as I told you, just read the question first of all. Analytic function with constant real part is constant. Okay, so your first step would always be let f of z is equal to u plus iv be analytic. This is the first step in every problem. Okay, always write this step. Okay, and what has been given to you? It is given to you that u is a constant, right? Now what you have to prove? You have to prove that f is a constant. Okay, so this is what you have to prove. Okay, so what is actually f? F is actually u plus iv. It is given to you that u is a constant. You have to prove that f is a constant. For that, what can you prove? It is enough to prove that v is a constant. Okay, now can you prove that v is a constant? Can you prove that v is a constant? You know that v contains x terms and y terms. So in order to show that this is a constant, you should show that it does not contain any x term or y term. Or you have to show that just Vx is equal to 0, Vy is equal to 0. Okay. If Vx is equal to 0, it means V does not contain x terms, and if Vy is equal to 0, it means V does not contain y terms. So in that case, your V will become some constant. So can you prove that? Okay, from what is given? It is given to you that U is equal to 6. U is equal to some constant. Okay, so what is Ux? Your Ux will definitely be 0. Your Uy will definitely be 0. Now if Ux is 0, you can say that Vy is 0 by Cauchy-Riemann equations, and if Uy is equal to 0, we can say that minus Vx is equal to 0, or simply Vx is equal to 0. So this means that the function v does not contain x terms, the function v does not contain y terms, so v will be a constant. Okay, so now you have got that your f is equal to u plus iv is just some c plus id, where c and d are constants. So if u is a constant, the function also, analytic function will also be constant. Okay, now can you think of a related problem? Okay, so the related problem would be analytic function with constant imaginary part is constant. So you can ask you that question also. So in that case, your v is given to be a constant. You have to show that the given analytic function is constant. It is very easy to prove. You just have to prove that u is some constant. Okay, so please try it yourself using the same approach itself. Nothing new is there. You can use the same methods. Okay, so this is the question, and now let us move forward to one important question which can be there for your examination. That is, an analytic function with constant modulus is constant. Okay, it's very important question. Okay, so let's start. So what is given to you? It is given that there is an analytic function given to you. Okay, f z plus u plus iv is there. Okay, and it is told that the modulus of this function is constant. Okay, so it is told that the mod of f z is a constant, some k. Okay, so you have to show that this f z is a constant. That is what you have to prove. Okay, how will you prove it? First, we will write what is this modulus. What do you mean by modulus of f of z? Modulus of z is simply x square plus y square, because z was x plus iy. So similarly, modulus of f of z will simply be u square plus v square. Now that is equal to some k. Okay, or you can say that u square plus v square is equal to k square. Okay, I'll call this as equation 1. Okay, I hope it is clear. I have just wrote what is given in the question. What is it? That is the modulus is a constant. So if f z is equal to u plus iv, modulus of f z is simply u square plus v square, and it is told that it is a constant. So I am calling it as k. Okay, now I told you in every problem we will be using CR equations. Okay, so in order to use CR equations, you should have ux should be there, uy is there, should be there, vx should be there, vy should be there. In every problem in the first module, we will be using CR equations. Okay, but now we have only got till u square plus v square is equal to k square. There is no ux, there is no uy, vx, vy, etc. So we are going to bring these partial derivatives into the picture. Okay, we will try to bring the partial derivatives. So for that, what I will do is that I will take equation 1 and I will differentiate with respect to x. Take equation number 1 and differentiate with respect to x. What will you get? You will get this as 2u into ux plus 2v into vx is equal to 0. Okay, or ux plus vvx is equal to 0. Okay, similarly, you can bring in uy and vy by taking one. If you are taking one and differentiation with respect to y, you will get a similar relationship like uuy plus Vy is equal to 0. The same approach, because this k is a constant, so when you take the derivative it will become 0. So ux plus Vvx is equal to 0, uuy plus Vvy is equal to 0. Okay. Now looking at these two equations, can you give me some can you find some common term in these equations? Looking at these equations, can you find some common term? Okay, so if you look at both the equations, you can see that u is common, v is common in both the equations. Okay, so what can you say? So from the first equation, I can write the value of u. What is the value of u? U is actually equal to minus vvx by ux. And in the second equation, if you look at the value of y, you will be getting this as minus vuy by uy. Okay, so minus vvy by uy. Okay, so both of these terms are same. So comparing, what can you say? I can say that minus vvx by ux is equal to minus vvy by uy. Okay, it is very simple. Yeah, I'm looking at these two equations and then I'm finding out a common value and then I'm equating them. Okay, so here u is common, v is common. So either you can form the value of u, or you can form the value of v, or you can form the value of u by v, or you can take the determinant as 0. So many methods are there. Okay, so anyway you can derive some equation by looking at these two equations. You can derive an identity here. So many methods are there. So I just took the value of u, which is easy. So I just took it like this. So this will be, you will be getting this. So these two terms are equal. So I can cancel out this common term minus v. So what will you get? You will be getting vx by ux is equal to vy by uy. Or in other words, you have, please write with me, only then you will understand. You have vx uy minus vy ux is equal to 0. vx uy minus vy ux is equal to 0. Okay, I hope it is clear. Okay, now what I am going to do is that now I am going to use the CR equations. What are CR equations? So you see, so my aim is to show that f is a constant. So I am going to show that u and v are constant here. So let us try to see how we are going to bring it out here. So for that you have to show that either the derivative ux and uy are 0, or the derivatives vx and vy are 0. So I have to show that. Okay, so my aim is to show that f is a constant. So I have to show that u and v are constants. That means I have to show that ux uy or vx vy is 0. Okay, that is what I am going to do. So I will show it from this relation itself. Okay, so for that I will use my Cauchy-Riemann equations. So what does Cauchy-Riemann equation say? It just tell you that vx is equal to minus uy and vy is equal to ux. So if you use that relation here, what will you get? So if I convert all this into just u, so you can convert it in any form, but now if I am just converting all this into just u, what will I get? This vx will become minus u. So I will be getting this as minus uy square, right? Vx I am taking as minus uy. So and similarly minus vy I am taking it as ux. So it is ux square is equal to 0. Okay, or else you can take in terms of v also. So because uy is equal to minus vx, you can also get it as minus vx square minus vy square is also equal to 0. So anyway you can get it. So from here, that is, now I have got that uy square plus ux square is equal to 0. Okay, I hope it is clear. It's very simple. So I'm just run through this once again. First you took this equation, then you took the derivative with respect to x, you took the derivative with respect to y, then you found a common term. From there you will get an equation like this, and when you simplify this equation you will be getting like this one here. Now I am going to convert this equation entirely in terms of u or entirely in terms of v. Okay, using the Cauchy-Riemann equations. Now we will be getting this quantity. Okay, now if you look closely at this quantity, you can see that here the sum of two things is actually 0. Okay, now it is not simple as two things, it is actually the sum of two positive numbers. Okay, because both of them are squares. Okay, so here the sum of two positive numbers has become 0. Why are they positive? Because we are taking a square there. Okay, now when will the sum of two positive numbers become 0? When individually both of them are 0. Okay, so that means your uy is 0, your ux is 0. Okay, so I hope it is clear, because the sum of two positive numbers is taken to be 0 here. So when will that be 0? When both of them are 0. Okay, because only then sum of positive numbers can be 0. So you will be getting uy is 0, ux is 0. Okay, now I hope you can fill in the rest. Okay, from this you can like in the previous result you can say that u is a constant. Okay, similarly from this itself you can say that vx is equal to 0, vy is equal to 0 by Cauchy-Riemann equations. So you will get that v is also is a constant. Okay, now you have got that both u and v are constants, therefore your f is a constant function. So this is a very, very important question. They can ask you for the examination. Please go through it. Nothing new is there. You just wrote what is given. First you took an analytic function, you wrote the given condition, then you brought in the ux and uy's. Okay, then you took a common factor outside, and now then from there you will be getting some relation, and there you are applying the CR equations to deduce the result. Okay, so please try to write it once yourself. It is very important. Okay, let us do an analogous problem. So these are the steps involved. It is given to you here. You can check it out. It's very simple. Okay. So so next let us look at a related question. Suppose there is an analytic. So since there is a modulus, I can also talk of argument. Okay, or argument of a complex number or amplitude. Okay, so that is what is it? It is given that is that tan theta is equal to y by x is actually the argument of x plus iy. Okay, so similarly, what is the argument of f of z? So I'll formulate a new question. An analytic function with constant argument. Okay, with constant argument is constant. Okay, so suppose the question is like this. How will you do it? So same approach only. So how will you do it? So I'll take f of z is equal to u plus iv. Well, that's the first step. And what is the argument of f of z? It is actually tan inverse of v by u. Okay, just as argument of z is equal to x plus iy is tan inverse of y by x. Here it is tan inverse of v by u, and it is given to you that this is a constant. I am going to call it as some k, or I can write this as v by u is equal to tan k, or I can write as v is equal to some c into u. Okay, v is equal to some c into u. Okay, so this is, so where c is a constant, I am calling it as tan k. So this is the approach here. Okay, so I hope it is clear from the given statement that argument is 0, argument is a constant, I will obtain this result. Okay, now since you have got v is equal to cu, okay, now we have to show that the analytic function with constant argument is actually constant. Okay, so now you have got this relation. Now how will you show that f is a constant? You can either show that u is a constant and v is a constant. So how will you do that? Okay, it's very simple. You bring in CR equations. For that you need ux, ui, vx, vy, just like the previous problem. So what will you get? You will get this as vx is equal to c into ux and vy is equal to c into uy by actually differentiating this function with respect to x and y. Okay, now look at the two equations. Can you bring out a common factor? It is c. So value of c is actually vx by ux, which is same as vy by uy. Okay, so from this two are equal. So you will get this as vx uy minus vy ux is equal to 0. So just like the previous problem, you can apply CR equations to get a relation uy and ux. You will be getting it as uy square plus ux square is equal to 0, just like the previous case itself. So you can fill it out. So that means your uy is 0, ux is 0, so u is a constant. Okay, so since the real part is a constant, your f is also a constant. So this is same, the steps are involved are just the same like the previous problem. Only difference is the relation will be like this because you are taking argument here. Rest everything is just the same approach. Okay, so please try to do this problem also. Okay, so show that an analytic function with constant argument is a constant. Okay, please try to do it by yourself. Okay, now one more question let us do. Show that an analytic function is independent of z bar. Okay, this is also very simple thing only by using partial derivatives you can do with it. So what's the question here? So you have to show that f of z is independent of z bar. So how will you prove that? Okay, so as I told you, u was a constant because u did not contain x, u did not contain y in the previous problems. Okay, so how did you arrive at that conclusion? Because ux was 0. Okay, when ux is 0, you can say that your u does not contain x terms. Okay, similarly, if uy is equal to 0, you can see that your u does not contain y terms. So how can you prove that f of z is independent of z bar, or how can you say that f does not contain terms involving z bar? You have to just show that derivative of f with respect to this z bar is 0. Okay, so derivative of dou f by dou z bar is 0. You have to just show that derivative of f with respect to this z bar is equal to 0. Okay, so how will you prove that? So this is what I am going to do here. Okay, I will show that dou f by dou z bar is equal to 0. Okay, so that is how we are going to prove that. Now how will you prove that? Okay, so already you are given that f is equal to u plus iy it will be in the form like this only. There will be no z terms at first, so you'll have to know how is this coming. Okay, you know that each of these u are uxy plus I and vxy. Okay, so each of these u and v are functions of xy, so there is no factor of z bar coming there. Okay, so from that you cannot conclude that dou f by dou z bar, because there is a problem here. You know that z is actually is equal to x plus iy. Okay, and what is z bar? Z bar is actually x equal to x minus iy. Now can you write x in terms of z? Can you write x in terms of this z and z bar? Looking at these two relations, can you write down? Okay, so x is actually z plus z bar by 2, just add them, and y is actually z minus z bar by 2y. Okay, so this x and y which are present in this u and v can have factors of z and z bar, contains and factors of z and z bar. Okay, so you have to use that picture there. Okay, so I am going to take, so I hope this is clear. I am just writing the value of x and y here. So how will you prove it? It's very simple. I am going to differentiate f with respect to z bar. Okay, now f is made up of this u and v. Okay, so by applying chain rule, you have studied chain rule in your previous classes, previous semesters. So u is a function of x and y, and this x is a function of z comma z bar, y is a function of z comma z bar. So dou u by dou z bar will be dou u by dou x into dou x by dou z bar, dou u by dou y into dou y by dou z bar. Remember the tree diagram which you have studied in your first semester. I am going to use the tree diagram, so chain rule there. So I'll write it down so you can understand. So this will be simply be dou u by dou x into dou x by dou z bar, okay, plus dou u by dou y into dou y by dou z bar, in this case, plus I into, okay, dou v by dou x into dou x by dou z bar, plus dou v by dou y into dou y by dou z bar. I hope it is clear, because when you take dou f by dou z bar, you will have to take dou u by dou z bar plus dou v by dou z bar. Okay, so you will have to find dou u by dou z bar plus dou v by dou z bar, right? So what is dou u by dou z bar? U is a function of x and y, and each of x and y is function of z bar, so it will be dou u by dou x into dou x by dou z bar plus dou u by dou y into dou y by dou z bar. Again, dou v by dou z bar will be dou v by dou x into dou x by dou z bar plus dou v by dou y into dou y by dou z bar. Okay, now tell me what is dou x by dou z bar? Dou x by dou z bar from this relation is basically 1 by 2. Okay, so dou x by dou z bar is basically 1 by 2, and dou y by dou z bar is basically, so if you look at this relation, it will be minus 1 by 2y. So dou y by dou z bar is equal to minus 1 by 2y. So you just substitute everything here, and then from CR equations you will be getting your answer as 0. Okay, it's very simple. If you want, I can do that also. So as base constraint is here, but let's just check it out. So it is actually dou u by dou x into dou x by dou z bar is 1 by 2 plus dou u by dou y into dou y by dou z bar is minus 1 by 2y, okay, plus I into dou v by dou x. What is dou v by dou x? It is just dou v by dou x itself, and dou x by dou z bar is actually 1 by 2 plus dou v by dou y into dou y by dou z bar is minus 1 by 2y. So you will be getting this one. Okay, now you just check it out. So you have dou x, dou u by dou x into 1 by 2 is there, and if you look at this quantity here, dou v by dou y into minus 1 by 2y, your I will get cancelled out, so it will be simply be minus 1 by 2 dou v by dou y. So your dou x, dou u by dou x and this dou v by dou y term will cancel out. Okay, you can write it by yourself, only then you will understand. Try to write it by yourself, only then you will understand that. Okay, similarly look at this one here. Okay, so this one is actually dou u by dou y into minus 1 by 2y plus I into dou v by dou x into 1 by 2. Okay, now this, you know that what is 1 by I? 1 by I can write it as minus I. Okay, so because if there is 1 by I, if I multiply the numerator and denominator by I, this will be actually I by I square, so it is simply minus I. So this 1 by I will become minus I. So in effect this term would become dou u by dou I into 1 into I by 2. Okay, so dou u by dou y into I by 2. Here also there is dou v by dou x into I by 2. Okay, now you know that dou u by dou y is equal to minus dou v by dou x, so it will get cancelled out. So everything will cancelled out and you will be getting the answer as 0. Okay, so please try to write it by yourself. I will give the proof here, but try to write it by yourself. This is the idea. Okay, you're just rewriting, rephrasing x and y in terms of z and z bar, and then you're applying the chain rule. Okay, so please try to do it by yourself. So this is the idea here. Okay, so you can just check it out. Okay, so moving forward, let us look at one more question. It's a very simple question. Two families of curves are said to form an orthogonal system. Okay, so suppose there is a curve like this. So family means your curves will be basically differing by a parameter. For example, x square plus y square is equal to some c. So there will be some circles like x square plus y square is equal to 1 is a circle is there, x square plus y square is equal to 2 is another circle, x square plus y square is equal to, so basically you will be getting so many concentric circles. So such type of curves are called family of curves. Okay, when you vary this c, you will be getting a family of curves. Okay, now taking two families of curves. Suppose this is one family and there is another family like this. Okay, so there is another family like this, it is going like this. Okay, so this is one family u of xy and some other family v of xy. You can see that these families are intersecting at some point. Okay, so we say that two families of curves u and v are said to form an orthogonal system if they intersect at right angles at each point of that intersection. Okay, that means the angle which is happening at each of these point of intersection should be 90 degree. Okay, so such curves are called orthogonal curves. Okay, so you may have studied about this in differential equations, but it is a very simple thing. Basically, you are getting basically, when will you say that two curves are orthogonal or two curves are perpendicular? When will you say that two curves are perpendicular? Okay, you may have studied in analytic geometry. When will be two lines be perpendicular? Two lines will be perpendicular when their product of slopes is actually -1. Okay, so two lines would be perpendicular when their product of their slopes will be -1. And what is slope? Slope is nothing but the derivative. Okay, so if your curve is actually y is equal to f of x, the derivative will simply be dy by dx. So you take the dy by dx of the first curve, you take the dy by dx of the second curve, and you just take the product. If you get it as -1, that means the two curves are perpendicular. So that is the idea which you will be carrying over here. So first you will have a function like this. You have been given that your u of xy is equal to some constant. Okay, so you can see that this is actually a function in x and y only. Okay, so this is like x square plus y square is equal to 2. Now can you find the slope from this curve? Just you find dy by dx from this relation. That will be the slope of this curve. Okay, similarly if your other curve is actually, suppose it is like x plus y is equal to 3, how will you find dy by dx? You just take just look at this relation, form dy by dx by taking differentiation with respect to x. We will be getting this as 1 plus dy by dx is equal to 0. From there we will get the value of dy by dx. So this is how you find the slope of the curve. So basically these are all some applications of this Cauchy-Riemann equations. It is not required for our further development. I am just giving some probable questions which can be related to this Cauchy-Riemann equations. Okay, so now I hope you understand what you mean by family of curves. Okay, and also what do you mean by intersection at right angles. Okay, so that is clear. So these are some basic ideas which you may have gathered from previous lower classes. Okay, so I'm just telling you. Okay, so the result which we are going to prove here is that suppose f of z is equal to u plus iv be an analytic function, we have to prove that the family of curves u is equal to c1 and v is equal to c2 are orthogonal to each other. Okay, so that is this. That means suppose your function u is equal to, suppose it is u is x square minus y square, and suppose your v is 2xy. Okay, so the question asks you to show that this if I'm taking a curve like this, suppose x square minus y square is equal to some c1 and suppose this 2xy is equal to c2, I have to show that these two curves are orthogonal or these two curves intersect at right angles. Okay, it's very simple. You take the first set of curves, find their dy by dx, take the second set of curves, find the dy by dx, so you will be getting the two slopes, and if you multiply the slopes you should get the value as -1. Only then it will be orthogonal. So that is the idea which we will be using here. Okay, so for this I was introducing to you the previous formulas. Okay, so let us, how will you prove it? Very simple. So in this case I am taking a general function f of z is equal to u plus iv. Okay, so I am looking at the first curve. For example, I am taking it some u is equal to c1. So so this is my first curve. Okay, so I am going to find the slope of this curve. So how will you find? I will differentiate this u with respect to x. So what will you get? U is actually a function of x comma y. So you will be getting this as, you may have studied total derivatives in your previous classes. Okay, so from that approach it will be dou u by dou x into dx by dx plus dou u by dou y into dy by dx is equal to 0. Okay, because u is equal to c1. Okay, so I'm differentiating. So I hope it is clear. U is a function of x comma y. I'm considering both as a function of x here. Why? Because of this relation. Because you can write y as a function of x here from this relation itself. That is why I'm considering y is also a function of x only. So here also you can write y as a function of x itself. So that is why I'll be considering this. Okay. Now how will you differentiate u with respect to x? It will be dou u by dou x into dx by dx plus dou u by dou y into dy by dx. Okay. So from this dx by dx is 1. From this you can write the value of du by dx. It is nothing but du by dx in the first case is actually, if I use the simple notation, minus ux by uy. Okay, so I hope it is clear. You just take this to the right hand side, then it will be ux minus ux by uy. So similarly, you can take vxy also. So I am going to find the slope of this one. So it will be, I am differentiating this with respect to x. So it will be dou v by dou x into dx by dx plus dou v by dou y into dy by dx. Okay, or your dx by dx is again 1. So your dy by dx for the second curve is actually minus vx by vy. So I'll call this as m1, which is slope of the first curve, and this I'll call it as m2, which is slope of the second curve. Okay, now if I take the product of m1 m2, what will I get? Suppose if I'm taking this m1 into m2, what will I get? You will be getting this as minus ux by uy into vx by vy. So what is that? That is ux vx by uy vy. Okay, just substitutionally. Okay, now ux is vy, so we'll get cancelled out, and vx is minus uy by, so we'll be getting this as minus 1. So we are getting m1 m2 is equal to minus 1. That is, the slopes of this two curves have product minus 1. That means they are orthogonal. Okay, it's very simple thing. Only thing is that you should understand what you mean by orthogonality. You must study the orthogonality in your lower classes, especially in the case of straight lines. I am just carrying over those ideas here also. Okay, so these type of varieties of questions can be asked, but everything could be solved by using this Cauchy-Riemann equations. Okay, so this is the proof of this statement. You can just go through it. If you have any doubts, please you can ask me in the live sessions also. So that's all. Okay, thank you.